Hey everybody, welcome back to my channel, Tumen Matt, and in today's video we're going to be looking at the second part of understanding the fundamental trig identities that are being used to solve and verify and evaluate and do all sorts of stuff with funky looking trig equations and trig expressions. So let's look at cofunction identities. So first up, we have sine of theta equals cosine of pi over 2 minus theta. We have cosine of theta equals sine of pi over 2 minus theta. Basically, they're kind of like horizontal shifts of each other if you've seen them graphed, which is why these cofunction identities work out. And we have tangent of theta equals cotangent of pi over 2 minus theta. Cosecant theta is equal to secant theta, secant of pi over 2 minus theta, and following. Because you can see there's a repeated pattern of pi over 2 minus theta. A good way to memorize these sort of cofunction identities is that you know tangent of theta and cotangent of theta. So the co part kind of tells you that they're cofunctions. So for example, we know that tangent of theta and cotangent of theta are cofunctions, and cosine and sine are cofunctions, and cosecant and secant are co-functions because of that co in the beginning. So hopefully that kind of tip or trick makes sense when you're using these sort of identities. But as you'll see, as you do a lot of trig identity work and kind of solving for trig expressions, that you won't typically use cofunction identities a lot, but still when they do come up, it's important that you know these important identities. Next up, we have even and odd identities. This is also pretty helpful when you are solving or evaluating or just working with trig functions or trig equations. First up, we have sine of negative theta equals negative sine of theta. Basically, what this is saying is that having seen what a sine function graph looks like, you can see that if you flip it horizontally versus vertically, it actually looks the same, which is pretty cool. But cosine of negative theta, on the other hand, is a bit different. And basically what this is saying is that when you flip the cosine graph horizontally, it actually looks the exact same, which is pretty cool. And then next up we have tangent of negative theta equals a negative tangent of theta, which is the same concept as the sine odd identity. And then we have cosecant of negative theta equals negative cosecant of theta, secant of negative theta equals secant theta, and cotangent of negative theta equals negative cotangent theta. As you can see, there's kind of a pattern that the reciprocals also follow the same identity. So since sine of theta and cosecant of theta are reciprocals of each other, they also follow the same odd identity. And the only even identities that are here is cosine and secant, which are also reciprocals of each other. I hope this video helped. Comment down below any of my topics from your review. Thank you.